amplitude, period, phase shift or horizontal shift, and midline or vertical shift. The amplitude is 1. The period is 2 pi over b, which is just 2 pi. I also like to write down the quarter period, which is just 1/4 of the full period. So 2 pi divided by 4, that's going to be pi over 2. The phase shift or horizontal shift, since there's nothing in there in the parentheses with the theta, it's just 0. No phase shift, and the midline is also 0. So to make my graph, I'm going to try to make a habit of like kind of making a box, and then I'll fill in the graph. So I'll start by plotting this point, which will determine the center left of the box. So my phase shift is an x-coordinate, so I'll go to the 0. And then the midline is a y-coordinate. So both of them are 0, so I know my box will be starting right here. To round out the box, to complete it, I know the amplitude is 1, so the top of the box will be up 1 and down 1. Now I just need to find these other 2 points to complete the box. The length of the box will be 1 period 2 pi in this case, so I go over there. And I might not actually always physically actually draw the box, but at least it'll be in my imagination, or maybe I'll dash it in and erase it later. And since this is cosine, I know it starts high and then goes middle, low, middle, low. I guess this is where maybe my quarter period comes into play. I will mark these quarter periods, and those are the intervals where I go from high, middle, low, middle, high, and from there I put in a nice curve. And maybe I'll erase the box. So I'll start by plotting this point. Then I'll go up and down by the amplitude. And then I'll go over by 2 pi. My little box. And then I'll put in those quarter periods. And because it's sine, I know it starts in the middle and goes high like that. So I start in the middle, go high, middle, low, high, then curve it in. B is still 1, so the period is 2 pi over b, or just 2 pi. My quarter period is that divided by 4, pi over 2. Phase shift. I think this whole worksheet doesn't have any phase shifts. Those are, I don't know, more difficult. So if we do see them, I'd expect it to be the later problems. But I'll keep filling it in. Phase shift 0, midline also 0. So start by plotting that point, and I'll start forming my box. Go up 2, down 2, then go right by the period. And I'll mark in the quarter periods. Because it's cosine, I know it starts high, then middle, low, middle, high. All right, more. sine. So it starts middle, high, middle, low. So to get a quarter period, to divide this by 4, I multiply the denominator by 4. Phase shift inside the parentheses is 0, and then the midline is also 0, the vertical shift. So plot that point first. I go up the amplitude, down the amplitude, and then over by the period. Make my little box. Then my quarter period is pi over 8. And because it's cosine, it starts high, middle, low, middle, high. And this one's going to be similar. Just copy the stuff from the last one since it has the same, all the aspects are the same, the amplitude, the period, phase shift. The only difference is it's sine. So instead of starting high, it starts middle. All right, moving on. Now we do see our first phase shift on this one. B is 1. Phase shift negative pi over 6. Midline 0. All right, this is more difficult. Earlier, I would plot this point first. I'll do that, but I can see the units of this graph don't have pi over 6's. So how do I plot pi over 6? I will probably convert this scale so that it does have a unit that I can plot pi over 6 on. So I will get the, I could turn this into fourths. That's not what I'm going to use, but if I did do that, I would be like 2 pi over 4. This would be 4 pi over 4. I'd have to convert all these fractions. But once I get a couple, I can, instead of converting them, I can just count this 2 pi over 4, 4 pi over 4, 6 pi over 4, 8 pi over 4. But that's not the unit I want because, that's not 6. So I need to get the least common denominator between 6 and 2, which is just 6. And I need to do that. I need to accommodate both things, the period and the phase shift, because both of these are horizontal. Both of these units will have to be graphable on this scale. But in this case, it's sixths. So let's see, I'll convert this to sixths. So let's multiply top and bottom by 3, because I want that to be a 6. So 3 pi over 6. Even from there, I can start counting. That's 3 pi over 6. This is 6 pi over 6. And I'm counting by 3's. 3, 6, 9 pi over 6. Oops. 3, 6, 9, 12 pi over 6. 9, 12, 15, 18. And I guess since I'm going backwards to negative pi over 6, I guess I'll need to go this way too. 3 pi over 6. Alright, it's still a little unfortunate because I don't have pi over 6. It's an odd scale. So if that's 3 pi over 6, I guess I'll have to break that into thirds, something like that. Terrible. Alright, so here we go. Negative pi over 6, 0 is right there. And then we'll go back to our the procedure we were doing before we make our little box. Alright, so we've got that point. Now we go up in amplitude, down in amplitude. And then we'll have to go right by a period, which is not just 2 pi anymore, because we're starting at negative pi over 6. So I'm going to have to do negative pi over 6 plus 2 pi. That's what I'm trying to do, negative pi over 6, and I need to go over to the right, 2 pi. Alright, so 2 pi is the same as 12 pi over 6. So 11 pi over 6 is 2 pi units away from negative pi over 6. 11 pi over 6 is 2 pi units to the right of negative pi over 6. So there's 12 pi over 6, so this will be the end of my box. I'm kind of just eyeballing 11 pi over 6. This is 9, 10, 11, 12. And then I need my quarter periods. I guess I could just eyeball this stuff. I could just eyeball halfway and then cut those halves in halves, but not sure if the teacher will accept that. So I will actually calculate the quarter period in terms of sixths, because that's my scale. So it's 3 pi over 6. So let me count over by 3 pi over 6. It's still going to be a pain. So it's negative 1, 0, 1, 2. That's 3 pi over 6, right? 1, 2, 3 pi over 6. That's my first quarter period. Let's see, what am I at? That's 2 pi over 6. So let me add another quarter period. Very difficult. So now I'm adding 6 pi over 6, 2 quarter periods. I'm not sure I should keep counting it because I'm not sure how accurate I'm going to be. Oh man. So I'll do it numerically. So my starting point, negative pi over 6 plus 2 quarter periods, right, 2 of these guys, equals 5 pi over 6. All right, so this should be where my halfway point is. This is 2 quarter periods away from my starting point. So 5 pi over 6, it's about right there. And then I'll have to add, maybe I'll just add another quarter period to that. So 8 pi over 6 is my third interval. Okay, and I'm right here at 5 pi over 6. I'm going to get to 8 pi over 6. So here's 9, so I guess I'll eyeball it. That's 8. Some teachers would want you to label these points also. Maybe I'll do that. 8 pi over 6, 5 pi over 6, 2 pi over 6. Since it's sine, it starts in the middle, goes high, middle, low, middle. All right, that was a lot harder than the last problems, and a lot of the reason it was hard is because our graph was in a unit that was not accommodating to our phase shift. And I had no choice. This was the graph they gave us. But if you're making your own graph, of course, it would be a lot easier if you had just from the start chosen your x scale to be in sixths. And it really wouldn't be that bad. So this would be like negative pi over 6. You could just 1 pi over 6, 2 pi over 6, 3 pi over 6, and so on. You'd have to draw a lot of these all the way up to 11 pi over 6 to get our full period in. But that would make the counting a lot easier. Then you could just identify a quarter period and just, you'd be able to just take 3 steps up, 3 steps up, 3 steps up. I'm not sure the teacher fully considered how she made this graph. Or maybe she did. All right, looks like we're gonna have the same problem here because the phase shift is in a unit that's not shown on this graph. All right, let's try it. So what's a unit? What's a denominator that I can't turn this into thirds, but I can turn it into sixths. Yeah, I need something that will accommodate both of these, which is sixths. So terrible. All right, 3, 6, 9. Yeah, I think I paused my video accidentally. I just have to guess where I paused it. So in this one, I had my phase shift, but I decided to convert that into sixths. I also decided to convert my period and my quarter period into sixths, since I made the scale of my graph have sixths. So and the reason that is because my phase shift was in thirds, but my graph was in halves, and my quarter period was in halves. So it was these two denominators that forced me to go to sixths. That was the least common denominator for 2 and 3. And then before I started graphing, I changed the scale. Like I said, I'd already done that before I paused. All right. So once I have my starting point, I graph that 8 pi over 6 is about like right there. So that's 6 pi over 6, 9 pi over 6. So 8's got to be right there. 6, 7, 8, 9. And then I go up in amplitude, down in amplitude. And then I usually draw the end of my box, so I need to add a period to my starting point. So my starting point was 8 pi over 6, and I add a full period. The period in this case is 2 pi, which is the same as 12 pi over 6. So I add my starting point plus a period, gives me my end point, 20 pi over 6, which is off my graph. So I had to extend the graph a little bit. 9, 12, 15, 18, 21, so 20 is about right there. And then I had enough information to draw the little box. And then I got to fill in these quarter periods. So my starting point is 8 pi over 6, and each quarter period is the same size. They're all 3 pi over 6. So I added 3 pi over 6 to get the first interval, 11 pi over 6. And I added another 3 pi over 6. Right, that's my quarter period, to get 14 pi over 6. Let's see, 14's about right there, just shy of 15. Add another quarter period. 14 turned into 17. My graph has 18 right there, so I put 17 right there. And if I add another quarter period, that gets me to the very end of the cycle, which I already have that point graphed. Once I have my quarter periods, sign starts middle, high, middle, low, middle. And then for bonus, I decided to go back a couple of quarter periods also. So I knew my starting point was 8 pi over 6. So I subtracted 3 pi over 6. 8 minus 3 is 5. This is 6, so this is 5. What a pain. And then I even went back one more quarter period. It's probably not necessary. Usually just one period is enough. All right, really happy to see this one doesn't have a phase shift. Those are definitely the worst. period is 2 pi, quarter period pi over 2. Phase shift 0, and it's our first time having a midline 1. And technically just the midline is y equals 1, which is a horizontal line. So if the teacher actually asks what the midline is, you don't say m equals 1. You would have to give this as an answer. But for me, I'm just going to say m equals 1. All right, so I start by graphing this point 0, 1, 0, 1. And I go up an amplitude, down an amplitude, and then to the right by a period. Luckily, I'm starting at 0, so it's easy to add a period. And I've got my little box. Quarter period's pi over 2. Sine starts middle. All right. This one's pretty similar, just the midline is down instead of up. So I'll start by graphing that point 0, -1. Up an amplitude, down an amplitude, to the right by my period, little box. Cosine, oh, I gotta do my quarter periods. Cosine starts high, middle, low, middle, high. It's a little bit subtle, the difference between the phase shift and the midline, because they're both like could be plus or minus 1, but it's the difference is whether it's inside parentheses or outside. This one's outside. If there had been parentheses there, this would be a phase shift to the right one. So outside the parentheses is a vertical shift. It's the midline. We start by plotting that point up a period, or up an amplitude, down an amplitude, straight away to the middle of the box on the other side, and these quarter periods. Cosine, high, middle, low. Dang it. So terrible, and it's the same thing, it's the 6th, which doesn't match, and this thing's really awkward to turn into 6th, because we have to like cut it into some uneven interval. Alright, so the common denominator is still 6. So I'm going to convert this into 6, multiply top and bottom by 3, then I'll start counting over 3, 6, try and write small. 3, 6, 9, 12, 15, 18. Alright, I'm going to convert this and this and this into sixths. Okay, I'm starting at negative pi over 6. That's my starting point. I'll add 3 pi over 6 to get my first quarter period. So negative 1 pi plus 3 pi is 2 pi. I'll add another 3 pi over 6, another quarter period, 5 pi over 6. Add another quarter period, 8 pi over 6. I don't need to add the last one, but 11 pi over 6. So I added 1/4, 2/4, 3/4, 4/4. So I guess this at this point I've added a full period. Normally I do that separately. I take my starting point and add a period, 12 pi over 6, pi over 6. But I guess that's the same as adding 4/4. So the end of my box will occur at 11 pi over 6. Here's my start, and if I go over a full period, it should end at 11 pi over 6. All right, up a period, up an amplitude, down an amplitude. Here's the end, up an amplitude, down an amplitude. And then it's 2 pi over 6 is my first quarter period, 5 pi over 6, 8 pi over 6, and then 11 pi over 6. Sine starts in the middle. B is 4, A is 1. This is D, I guess, or my midline, 2. C is 0, so the phase shift is 0. And then my quarter period is pi over 8. So I can see that's not on my graph, but pi over 8, I guess that's easy enough to graph, since each of these is a quarter of a pi. It's easy to make 8s of pi's. So I don't have to worry about any common denominator thing, I guess. We'll see. All right, so I get my starting point, 0, -2, up an amplitude, down an amplitude, and to the right by a period, which is pi over 2. Not too bad. Then my quarter periods are pi over 8, which I can just cut this in half and then cut those halves in halves. But yeah, that is pi over 8. And cosine starts high, middle, low, high. Oh, middle, high. All right, for this one, they're giving us sine and they're asking us for tangent. And you can see they've got these negatives in here. Just there's no question we're going to use these even odd properties. So we prefer not to have that thing, so we can use this property to get rid of it. We don't mind the negative outside, so let's change that. This thing tells us that sine of a negative x is the same, can be replaced with negative sine of positive x. Sine of negative x can be replaced with negative sine of positive t, which means sine of t will equal -2/3. And sine and cosine are like the most fundamental of the 6 trig functions. So if we can get those two, we can figure out all the rest. So let's focus on that. To calculate cosine based on sine, I need an equation that has sine and cosine in it, which is right there. Pythagorean. So I'm going to replace that sine squared with my value for sine. And that's sine squared equals 1. Now I can simplify all this and figure out what cosine is. So it's cosine squared x equals, this will be 4 over 9 positive, and then I'll move it to the right. It'll be 1 minus 4 over 9. It's 5 over 9. Then I square root. And don't forget the plus or minus. I'm going to get plus or minus root 5 over 9, which would be root 5 over 3. Now, how do I choose plus or minus? Well, they restricted us to a certain quadrant, the third quadrant. So I know now I can choose, do I want positive or negative? Is cosine positive or negative in this quadrant? Since cosine is horizontal, cosine is the x coordinate, or however you want to think about it, but cosine is negative in this quadrant. So that means I can get rid of the positive. So for us, cosine is negative root 5 over 3. And for tangent, I also want to get rid of that negative. So I come over here. In tangent's case, also it becomes just negative tan of regular old t, positive t. And then since tangent is sine over cosine, I can replace sine with negative 2/3 and replace cosine with negative root 5 over 3. I could cancel those negatives and then flip and multiply. Those 3's cancel, you get negative 2 over root 5. I'm sure you're supposed to rationalize that. So negative 2 root 5 over 5 is the final answer for tan negative t.